Good morning. Thank you for your attention and to be present. Our industry is changing very, very quickly. Many of you know this. The water industry is leading the globe in some of the radical changes with respect to our environment. And so what I'd like to talk about this morning are some things that are moving us in this changing direction. Demographics across the globe are showing that we can support as a globe the 9 billion people that we expect to see by 2050. What we're really struggling with is this fact. So the challenge that we have in the water industry is not necessarily we have too many people, but that we have too many people in concentrated places. And the question is, what are we doing about it? To put this into context, when you look at what happened in around 1950, there were about 6 cities globally that had what we call a mega city feature. Mega cities are typically defined with having 5 million residents or more. You fast forward that to 2015, and that number completely accelerated up to 66 cities globally. What does this mean from the environmental perspective? These cities, of course, consume incredible amounts of energy. They consume incredible amounts of extracted resources from our environment. They are the largest emitter in aggregate of our greenhouse gas emissions. Demographers are even thinking about what it might look like now with respect to these cities by 2050. Again, where are these 9 billion people going to be living? And the projection is that that 66 number will grow to 104 by 2050. As you can imagine, this creates a substantial amount of challenge for us in not just the environmental industry, but of course in the water industry. Research shows that the amount of waste that we're generating in the 66 cities today will double by the time we reach 2055, and it will more than triple by the time we reach 150. What are we going to do about this? So this brings me to my challenge for our discussion this morning. I'd like to talk a little bit about what these challenges are and think about it in the context of a circular economy that may be a means by which we can address these challenges. I believe the wastewater treatment facility, which we now call water resource recovery facilities, have a role to play in this circular economy. We'll talk about that. I also want to be very clear that there's a lot of realities that see obstacles in our way. And I want to offer an alternative approach to maybe how we can work around these obstacles in a pragmatic fashion. So I believe in the future, in this 21st century, we have 3 fundamental major challenges. Urban migration, as I mentioned, resources that are becoming scarce and are not just scarce in areas where there are urban areas, they're also scarce in rural areas. And then, of course, the pollution impacts that result from these things. So how are we doing so far? Unfortunately, the resource consumption that we see globally is continually on the rise and increasing, as we know. And our current response to climate change is very ineffectual, in my opinion, from a global standpoint. So this creates more challenge for us. But perhaps maybe even of more concern is that we continue to neglect the amount of impact that this has on the social fabric of our globe. And I think that has other geopolitical concerns that we may or may not have time to talk about. So what is the story in the globe from the water perspective? The research has shown that by 2030, the amount of available water on the globe for our use from what we are demanding today will have a gap of about 40%. What are we going to do about that gap? Basically, what it means is that 2/3 of the global population by 2030 will be under high water stress. This is a serious challenge for us in the water industry. You know that water and energy are intricately linked together, and so the story on the global energy picture is very, very similar. Here again, because they are so linked, we find that the amount of energy that we are demanding by 2030 and the amount of energy that will be available for us to be able to use in that period of time, again, has a gap of about 40%. But here's the real issue. 75% of that energy is going to continually be provided through the fossil fuel realm. Unfortunately, in order for us to close this gap, we have to build. 70%, it's estimated, of the infrastructure that's requisite for this energy production that we need to be able to support this 9 billion in 104 mega cities is not yet even built. And you can imagine the amount of investment that's going to be required and already is being required of us to not only build the infrastructure capital, but then to decarbonize that infrastructure from this 75% being provided by fossil fuels. So the issue is not about we don't have enough energy in the world. As a matter of fact, this graphic illustrates how much energy we do have in the world in the context of fossil fuels. There's a lot out there, and we're going to continue to see a lot of it being used. But this is a challenge now for us from the standpoint of the water industry and how we relate to that. Energy has always been the driving force for economic development around the globe over millennia. And this is really, really important because of the impact it's had on environment. It's always been linked to the environment. Sure, we've been able to produce great things with the energies that we've had. We've had great agriculture, we have great advanced technologies, we have commerce, so forth and so on. But environment has always borne the ultimate price because we haven't been able to appropriately allocate the true costs associated with the externalities of extracting resources from the natural environment. So what we really need to do into the future, and in order for us to meet these challenges in the next half of the century, we have to learn how to decouple this dependency of economic growth on the environment. And when we decouple that, we actually can assure that we can have strong economies, and we can have a healthy environment, and we can have megacities that are actually livable and sustainable in the future. So decoupling, by definition, really occurs when we take resources that we had originally extracted from the environment and created products from those resources. And now when those products' use have reached the end of their life, if we can find a way to recycle the value of those products and put that value back into the economy, we are displacing the actual resource that we extracted originally, and we are reducing that. And when we displace extractable resources with recycled things, we find we can decouple this intricate link between economic development and environment. When you think about how much of the global material movement through our economies occurs on an annual basis, 44% of all that material that moves through our global economy is rested in carriers of energy that are once used, not renewable. So I am absolutely convinced that to be a sustainable community in the future as a globe, we must focus on that 44%. So the circular economy, in my view, is the pathway to the future, and it's a sustainable pathway because of the following. Our traditional approach has always been to be very linear in our thinking. We extract resources from the environment, we develop products from those things, we use those products to the end of their life, and we dispose of them in a linear fashion. What we know is that it causes a depletion of those resources that we've extracted, but what really from an economic perspective occurs is that we see tremendous price volatility on products. And it minimizes our ability to stay within the boundaries of our planet environmentally. So the new concept for us to be thinking about in the 21st century is this idea of circular economy, where we take these resources and we use the products and we recycle and bring those product values back into our local economies. Currently, right now, about 62 gigatons of material is passed through our global economy on an annual basis. Only 7% of that is being currently recycled into what I would call circular economy value. And so the European Commission, for example, has taken this very, very seriously. And they have put out 6 billion euros on an annual basis to all the members of the European Union to focus on improving their abilities to do these kinds of concepts. And so it will indeed displace the resources that we have primarily extracted, and it will maintain, and it has maintained, some economic growth where we can attach value to these things, and it will reduce the environmental impacts. Unfortunately, we're not paying enough attention yet to the institutional impacts it has on our social fabric. I am a complete believer that the ability of our wastewater treatment facilities to become part of the circular economy is absolutely paramount for our sustainability in the 21st century. When we think about all the things that we have an opportunity to recover from the wastewater that we treat on a daily basis, first and foremost, we should be recovering every drop of the water and its fit for purpose use should be right in our local communities, every drop. We also know that we have plenty of nutrients that we can recover for agriculture. We have energy that we can recover in the forms of generation of power, whether it's for the local or extended grid systems. But the new thing that's happening now on the horizon that's moving into our treatment facilities is the recovery of carbon for the use of recycling carbon organically back into our environments through bioplastics, biofuels, and so on. I'm absolutely convinced that every waste stream that comes into the plant has a value, and we need to extract that value from it. Furthermore, I think by clearly seeing where these recovery opportunities are, we are replacing those extracted resources from the environment. These are examples of some of those kinds of resources that we know are already embedded in the wastewaters that we should be recovering. In some cases we are. In some cases we are just thinking about it. In other cases the research is proving that yes, we can, and we should move quickly in this direction. Traditionally, the academic towers of industrial ecology and environmental economics and so forth and so on have focused very much on what I would call the upstream side of recovering resources. Basically saying if we can work at the upstream end before resources have been used and abused, we then have a better opportunity to recover those resources and put them back in the environment. Well, unfortunately, as you all know, our infrastructure that we have is already built. So we have pipes in the ground, we have pumps in place, we have treatment facilities in place, and these things are tied to the watershed in a way that it forces us to really think about what's going on at the downstream end of our resource use. And so these academic towers that you can see that make up this ladder here, circular economy falls down at the bottom because we are at the end of the service life of these products. And the wastewater facilities that we have around our globe are working with products that are at the end of their use, primarily with respect to water and chemically embedded energy. And as such, I believe we can focus on the end-of-life uses of all these embedded energies and products and then bring them back into the upper levels of these ladders to bring value to the economy. But we have to understand what the value proposition is, and this is something that I like to think about in terms of what I call the value pyramid. And when you look at this pyramid, what basically is happening is that as you move up the pyramid level, you will increase the value of the product you're recycling. As you move down the pyramid, you're basically increasing the volume of those products that you're recovering. So when you think about it from a standpoint of a wastewater treatment facility, all the biogas that we produce from digesting biosolids and so on, all that has a great deal of volume. It has lower value, but it has a great deal of volume. And think of it this way, as you move up this ladder of pyramid, as you get closer to the top, the things that we are recovering have a closer association with the protection of public health and human health and environment more and more directly. So as you move up the ladder with respect to carbon, with respect to nutrients and so forth, you find as we get higher and higher, we're getting closer and closer to actually directly impacting human health and environment. So the actual value of these things increases as you move up the pyramid. Just to give you a quick example, if you look at materials and chemicals in the middle, you have cellulose coming into the plant, we have bioplastics that we can generate from the carbon, we have phosphorus that we can recover, and we have organic acids that are present that we can also recover. And that is a prioritized intentional list in terms of its value. Cellulose is basically a non-valued product with respect to human health because this is primarily the fibers that come in with toilet paper. You move up this chain and you get up to organic acid, and these are things that actually can be utilized in pharmaceutical products, which is directly related to human health. So this is the idea. We want to be able to capture as much of the volume as we can, but move up the pyramid with a higher value because this is what brings the economic decoupling. We do have a value proposition in the form of biosolids, as I mentioned a moment ago. This is a big area of research and is still going on, and there's about a 90% increase in the value of the actual use of biogas expected between now and 1950 if we continue to generate as we can. We know about nutrients. In the form of nutrients, when we think of the global amount of nitrogen and phosphorus that's generated in human urine and feces, just take the numbers and do a quick calculation on the total world global population. If we were to capture all the nutrients of nitrogen, phosphorus, and potassium that's present in the urine and the feces that we as human beings develop, we would find that we would make up already 1/3 of the total current global nutrient demand created by commercial fertilization that we are producing today. Similarly, though, if I know that there's a lot of other kinds of sources of nutrients, for example, food waste and animal waste, if I include that in that sum, interestingly now, I end up with having 3 times the volume of nutrients available to me from the globe than what it is I'm extracting from the primary resources that we are using today to make nutrients. So this is something that creates a value for us. But as I mentioned early, we know we have obstacles in front of us. And what are some of these obstacles? We want to be transparent about these things and talk to each other and talk to other industries and try to understand how we can work with these. Too many people today still believe, and I'm talking mostly from a North American perspective, that these recovery processes are still too expensive. Capital's too high, I don't want to spend that money. And as a result of that, many people have a perceived ROI that it's way too long. If it takes me 10 years, 15 years to recover my investment, that's too long for me. It's not a good business decision, and this is an obstacle that we struggle with Wall Street. We lack the infrastructure to support a lot of these recovery systems. So let's take urine separation, for example. All of our current infrastructure in US, we don't have the capability to go back and retrofit easily or cost effectively to do urine separation to be able to recover that. So that's a somewhat of a physical obstacle. But here's something that's very interesting. We talk about design, build, operate, and finance. These delivery models, I'm convinced, which are designed, of course, to reduce the schedules of time and to be more cost effective in terms of capital construction. Unfortunately, what that does is that it allows us very, very little time and patience to do the research that's necessary to be able to show that such and such of recovery can actually provide value to that community. So I'm concerned because all of these kinds of barriers favor incumbent systems. It favors us continually putting back what we've always known how to do and repeat the same thing over and over again because that's our perception of cost effectiveness. Of course, we have regulatory challenges, and then we have something known as a rebound effect, which I'll talk about. From a regulatory perspective, we currently, from a resource recovery process, if you think of this in terms of the direction of the supply chain here, this is an example of the regulatory oversights in the UK. Look at all the different types of agencies that are overseeing the various parts of the supply chains in the UK for recovering resources, and look at the overlap that they have. This creates a tremendous amount of confusion for those who want to do resource recovery because it creates a great amount of uncertainty about who's going to control what and what are going to be the compliance challenges they have. And matter of fact, compliance, in my view, it only incentivizes for you to divert waste. It does nothing about what to do with what that waste can be done after it's been diverted. And so we need to think about how these regulatory overlaps need to be corrected. We could also take a look at that and say, what about the risk? Who's going to be willing to accept the risk for these recovery products and their value and the use that they have back in the environment and in the community? One way to do it is what's called a distributed chain, where we allow each of the distributed portions along that supply chain to assume the risks that they're providing. Some, however, feel that the utility needs to take all the risk so that it can control how these products that are embedded in wastewater, for example, can be reutilized throughout the community, and they assume the risk and the control of that. That's called a consolidated value chain. We see models on both sides and advantages and disadvantages to both. But we really have to be concerned about something known as a rebound effect. The rebound effect, basically, as I've defined it here, it's just basically an immediate increase in the demand for a product, and the consumption of that product is attributed to the lower prices that are often associated with a recycled product. I call this the Prius effect. And we saw this in North America back in 2000, 2002, when the Toyota Corporation came out with the Prius. And back in that time, we were paying $4 a gallon in the US. And when the Prius came out, and we were typically getting 15 miles to the gallon, all of a sudden we could drive 50 miles to the gallon. We had tremendous in response to that, and we did nothing to change our behavior about how much of the formal extraction of resources of fossil fuels. We just drove a lot more, right? So it did really nothing for us. That's called a rebound, and we want to minimize what that can do. And then what we have to do is we have to stop creating a false impression that there's no net environmental impact from these recycling activities. We have to calculate in the external costs associated with the recycling and recovery process and make sure people understand what that means. And so that has a marketing impact for us, and we have to make sure that all the products that we are marketing are marketed as primary products as if they were exactly the same as that which was extracted from the primary resource. We also have to make sure that there's no net effect on the aggregate demand, right? We don't want to decrease demand over these products. We want these products to come back and have the value, and that means the consumer must see that these products have just the same value that they had when they were originally brought out. So these are obstacles that we're working with, and I would offer the following alternative. I believe that we need to change our thinking in about how we do treatment, how we recover resources, and why. And I believe that we have to change our view from looking at ourselves and how to do things and now looking back at what nature has taught us. This is a concept known as biomimicry. It's not a new concept, but it's a new way of thinking. Biomimicry basically means I'm going to extract design principles from nature to apply all our human challenges. So what does this really mean? Nature, if we think about it, can be a model for us. What is a model? A model basically says, this is the way in which we, meaning nature, has learned how to operate over 3.8 billion years of evolution. We have 30 million species in our world today that we know of, and those 30 million species have learned how to work together to solve any problem that you and I will ever see in our lifetime and in the future. It can also be what we would call a measure. So the measure here would just basically say, I've got to design not with nature, but as nature. And this is the measure or the benchmark that we should look. If we look at how nature and the ecosystems that operate within nature, and we would design our systems as those, not with them, but as those, we would find a huge change. And then thirdly, I think we have to recognize that nature can be our mentor. We must be able to learn from nature from what it has taught us over all these years of evolution. And if we're willing to learn, I think we will see a change. This is an example of what I mean. I'm going to share 3 examples of this biomimicry concept. This particular wind turbine blade is being constructed by a company known as Siemens, which many of you know of. They coupled with the Gaius Corporation in Germany to develop this wind turbine blade. Many of you know that the wind turbines, when they first came out, struggled environmentally with affecting the migratory patterns of birds, primarily due to acoustical imbalances in these systems. They were also highly inefficient in terms of the amount of power that was generated from the turbines. So these engineers and scientists went back and started to look into nature to how to solve this problem. Did nature have an idea? And they found with the barn owl that you see at the top there, on the wingtips of that owl, it was shaped in such a way, the feathering of those wings under certain speeds allowed the acoustical difference of the air pressure moving over those wings to go away. There's not a sound. You cannot hear the owl coming. And so when they applied this, which you can see those little teeth on the wings leading edge of that turbine, they dramatically reduced the impact of acoustical challenge. They also recognized that to build the efficiency of the motor, they had to do something with the way this blade was shaped, and they went to nature and they found, sure enough, with the humpback whale, the shape of the dorsal fin of the whale was allowed to make that whale make incredibly sharp turns. These guys are 19 tons. They can make incredible sharp turns at very, very high speeds with high efficiency. When they applied those principles, dramatic increases in the efficiency of these motors. This is where an example where we had a problem and we went to nature and we looked for a solution. We can do this in transportation. Some of you that may have been to Japan have ridden on the Shinkansen high-speed train. When they first designed these systems, they found tremendous amount of acoustical shock waves occurred when these systems came into the tunnels. And it actually was creating a shock wave over the entire train that was actually damaging portions of the train. And so they felt, what are we going to do about this? And they went to the nature and they found, interestingly enough, the kingfisher. If you look at the shape of the beak and the shape of the head of the kingfisher and the shape of that locomotive on this train, if you want to call that, you'll find they're exactly the same. And when they applied that kind of application to this solution, They found, sure enough, just like the kingfisher that can dive at full speed and not have a shock wave to affect its brain, they did the same thing with this, and the Shinkansen has no issues with this anymore when it enters tunnels. We also can think about it in terms of another idea of thinking. Instead of having a problem and going to in nature and try and find a solution for that problem, how about if we just go and observe nature first and just learn from nature and understand how nature is addressing certain issues? Here's a large one of these termite mounds in Central Africa. These stand about much as 5 meters in height. And when you dissect one of these things, what was very interesting to the scientists studying these, who were just observing, they found that how in the middle of these deserts that are 35, 40 degrees Celsius, can the temperature throughout this entire thing be a constant 31 degrees all year round? And they found when they dissected it, all kinds of cavities, all kinds of corridors, all kinds of hallways that these termites and stuff have built, and a way that it moves the air through there in a highly efficient manner, and there's constant cooling. So what did they do? They said, aha, now this is an interesting solution. Let's go find a problem. And this was applied to the large office center in Harare in Zimbabwe today. They reduced the energy consumption of this building for cooling by 90% by applying these same principles. This is a proactive way of going to nature, observing, learning from it, and applying it to a problem. So how do we bring biomimicry then into our industry? I'm convinced that for the future, part of our meeting these challenging problems in the urban setting is that we have to first bring our nature to the system in the urban setting. And this is an example of what's known as the food factory, where we're addressing the idea of energy, we're addressing the idea of growing food, and we're addressing the idea of treatment, capturing nutrients, recovering carbon, and making carbon sinks. It's basically a sequential reactor where each of these sequences provides a different type of ecosystem to be able to resolve the treatment. We also have something known as the living machine that we're starting to see a lot of work being done on the full scale. The living machine is in a similar idea, but here what we're doing is we're taking advantage of the ideas of biofilms. We've learned an awful lot about biofilms in the treatment world in the last 20 years, and now we're learning to realize that, you know what? Nature has used biofilms for eons, and why can't we use the same kind of idea here? So here's where we use the actual water itself and recover the water, and then we use these slats that you see vertically hanging. These are called biofibers, where we grow very, very distinct types of biofilms to be able to remove nutrients, number one, and recover those, and remove carbon. The other interesting thing, if we're going to deal with these mega cities in the future, many of us know that for our traditional way of understanding how we feed the world is that we've done everything on a horizontal basis. We're running out of arable land to grow the food that we need for these mega cities. But if you've taken a look at all the amount of area in a city that is vertical, maybe we can take advantage of that and utilize the vertical space that's available in our cities and move upward with something that we call living walls. And in these living walls, we're going to grow food, we're going to capture carbon, and we're going to reuse water, and we're going to reuse nutrients and carbon in the same way. These are two examples of living walls that are currently operating in the UK and just outside of London, and this is exactly what they're there to do. They're there to remove carbon from the atmosphere, they're there to provide food, they're growing various species of food on these living walls vertically. We can take this one step further from the water reuse perspective and think about all the vertical space that we have on plate glass that now also, when you provide these living walls, creates an area of cooling. So we tremendously start removing the amount of energy demand, primarily in the larger cities, in the arid areas of our developed countries, where we can do the cooling using plants, while at the same time growing the food that's necessary for that population that's growing, while at the same time recovering the nutrients from the separated organics, as well as the urine that's present, and recovering carbon products as well. And then finally, I would give you this real-life example as well. I'm also convinced that the reason why the wastewater treatment facility, which we now call the Water Resource Recovery Factory, this is the reason why I'm such a strong advocate of converting these plants into these factories. Because unlike any other industry, The wastewater industry is the one that has the opportunity to return into our economics all of these different types of recovered products better than any other industry because we have so many different things available to us in the waste stream. And as a matter of fact, this is an example of where we're using this nature biomimicry idea of this very wonderful organism called algae or microalgae. This is a plant that's under construction today in the state of Utah, which is in western US. Arid area. That plant is about a 28 MLD size plant. You can see it's a trickling filter works. They are now required to remove nitrogen and phosphorus to very low levels, according to the new state legislation. Those filter works were unable, obviously, to remove those nutrients from a regulatory perspective. But this particular utility got to thinking, we want to be part of the future. We want to be cognizant of how to reflect that need that we have in our community to be reflective of nature and to be responsible to the environment. And so they are constructing what's called a microalgae plant. The microalgae is specifically, from a regulatory perspective, there to be able to remove the nitrogen and phosphorus to low levels. But what's really important is the water that is recovered from this can be utilized for fit-for-purposes uses both on-site and off-site. Secondly, or I should say thirdly, the energy that is developed from the growth of the microalgae can actually be used in digesters in other areas. They don't have the digesters here to do that, but they have other opportunities to do that, to generate biogas. But the real important thing for them is that they are taking the product of the harvested algae and selling it to a company called Algix. And Algix is a group that takes the polymers from the algae and creates a foam, a bioplastic foam, which goes into the sole and the heels of many of the shoes that many of you are wearing, primarily running shoes. This is a new way of using the product as opposed to using general rubber. They have a contract for 10 years to provide this biomass at 70 cents a pound. And all of that money is coming back into the plant to continue to provide offsets for O&M, as well as to provide opportunities for new capital. I love this idea because it's able to give you a recovery of the water, of the nutrients, of the energy, and all the products. So moving forward, I think my final comment would be this. I believe we have three pillars that we need to focus on in our coming 50 and 70 years to meet these challenges we have. If we're going to be a globally sustainable industry, I think we must use resource recovery and we must drive it from the circular economy value. We must put value into these products and create those values as a value proposition for our communities. It will decouple the economic growth from the environment. We must use what I would call bio-inspired design. We must design as nature, not with it. And when we take that kind of concept, I am convinced we will transform our industry and we will meet the challenges of the future. We have to displace all the resources that are being extracted. And until we do that, we won't do that decouple, but I believe the wastewater facilities can and are in a unique position to do that. And I think you and I, as people, need to recognize that we cannot neglect the social dimension of this. We have to bring our partners of all industries, our partners of other industries, into this sandbox with us. We cannot neglect the social justice that this recycling creates for all. So some key takeaways. Urbanization obviously is the pressuring of our global economy. It's the pressuring on global water. It's the pressure on global energy. We understand the challenges to some degree of urbanization moving forward, but we don't understand it all. I think resource consumption is inextricably linked with economic growth, and I think the research clearly shows that, and we must decouple these two if we're going to have a sustainable future. Does the future appear grim? Many would say it does. I would argue that there's hope on the horizon. Just to give you a quick example, this past April is the first time in U.S. history when renewable energies in aggregate, wind, solar, geothermal, when you put that in aggregate, we surpassed the production of power than we use for coal. That was the first time in history. So I'm very, very encouraged that we're beginning to get it, but the future continues to be a challenge for us. I believe by decoupling, we will move into a circular economy that takes us into a future. Circular economy has to be our objective. And if it's not, we're going to continue to repeat these incumbent solutions over and over again that will not get us to where we need to go. And I believe to do what we have to do at the urban area, we must embrace biomimicry at the urban area, on the urban ground. We have no other area to do this anymore, and we must move our systems into the urban setting, and the only way, in my opinion, to do that is through biomimicry, and we must embrace it. And it embodies everything about the circular economy that we believe is true. So are they the bullets? Are they the silver bullets? I think they're the gold standard, frankly. Yes, they are the magic bullets, and I believe this is what is going to take us into the future, if and only if we follow the following axiom. I would suggest that let's all make a commitment to one another to working on the right things to do, and I think we should avoid, in all possible ways, at making things simply less bad. This is, to me, fundamental to our future. We've got to stop making things less bad. Even though it may look like we're doing the right thing, are we really truly doing the right thing? And I believe by going into the circular economy and using a biomimicry ontology, we're going to get there. Thank you very much.
Thanks, Art. Fraser Clark from Wellington Water. Just a question around a challenge with extraction is that it often comes with a high energy cost. We see that in kind of raw product extraction. What are you seeing in terms of resource recovery and the balance between extracting value from these products and the energy cost of doing that?
It's a great question. And I think my response to that, because you're absolutely right, one of the fallacies that we've had with circular economy efforts is the assumption that we can just simply recycle something and put value back into the economy and it will automatically do this decoupling that I described. What we're learning more about is that we need to spend a lot more research time on understanding what the externality costs to recycling are, right? Because it does take energy, it does take labor, it does take resources of other kinds. And what we also learn is that every time you recycle a product through its use, it's actually decreasing its value because it loses structure. A good example of that is cellulose. So if I recover toilet paper, for example, the fibers in that toilet paper, every time I make a new piece of paper or a new piece of cardboard, the fibers actually shrink, right? And so I need more fibers and I need them to be under a different type of polymeric kind of structure to be able to make the same strength. And so we're not taking those kinds of costs into effect. That's one. The second thing is I do not believe that we're taking the costs socially into that effect. So we're putting products that are of lower value back into social fabrics of our society that we think, well, that's good enough for them. It's not good enough for me, but it's good enough for them. So we have a social economic justice question to resolve there too. And when we put these two together in aggregate, I'm convinced then we'll have a better picture that's not just an academic tower picture of what circular economy needs to do. But we have a lot of work to do on that.
Round of applause for Dr. Art Umble.